So, welcome dear students. This will be the first lecture for your MATLAB course, and I'll just start with introducing you to the IDE, and then we'll see how to use MATLAB. So on your screen, you can see the MATLAB application, and it has some parts which are labeled as this. This window, this area here, is the current folder area, which basically specifies the the location pointed to by this path here. So it says see users, name of the user, documents, MATLAB, and this is the folder where I'm currently working, and these are the contents of that particular folder. We'll later on see how we use this uh, current folder, the home directory, to create scripts and so on. The other part of the IDE involves the editor. So there, here I have opened a lot of script files which I've earlier created, and you can write your own scripts here, and we'll again see how to do this later on when we go through the basics. This window here, known as the command window, is where you basically type in the commands for MATLAB. MATLAB is basically an application which has been designed for working with matrices, as the name suggests, MATLAB Matrix Laboratory, and it provides a lot of predefined functions and libraries that you can use to write computational scripts for varied application domains like image processing, fluid dynamics, and so on and so forth. In addition to, let's suppose, for machine learning, deep neural networks, and so on. So other parts of the window include this is the workspace. It helps you to give the variables that you have created. We'll later on see how to define variables and how to give those values. So this is the workspace area, which will hold all the variables that you have created. And this here is the menu bar, or the shortcuts to various options that MATLAB provides, like creating a new script button, opening some existing files, saving the scripts, and so on and so forth. There are some other options as well, to insert comments, block comments, to insert sections, functions, indenting your script. That will be done later on. To insert breakpoints, to debug your, for example, scripts, and so on, to run a script, and so on and so forth. So we'll start with the basics, and we'll start with the command window. This prompt here is where you type in your commands. So let's start with first using MATLAB as a calculator. So if I type in 3 plus 6 and press enter, it creates a variable named answer. Okay, and it saves the value of this equation here that you have typed in, and stores it in this variable answer. And you can see in the workspace it creates this variable answer and puts the value 9 in it. So similarly, you can use different expressions. So 3 multiplied by 5 plus 3, and so on and so forth. It overwrites the value of the answer variable. Now it's 33, and in the workspace you can see the answer variable is the same as it was earlier, and the value has, however, changed. So this is simply using MATLAB for evaluating some expressions. Now let's suppose we want to create a variable to store a value. So let's suppose I'll write x is equal to 1 and press enter, and you'll see in the workspace you can see that this x variable has been created, and this value 1 that we stored here, assigned to this x, has been stored. Now you can see whenever I write, let's suppose again I'll write x is equal to 1 and I press enter, it echoes back the name of the variable and the value that is in. Okay, if you want to if you want MATLAB not to echo these statements, you can use a termination operator to at the end of the statement, like x is equal to 1, and press and write a semicolon there, which acts as terminator, and you press enter, it will not echo the output of this expression on the command window. So let's create two variables. So x is one of the variables and y is another variable. I put 2 in it. So in the workspace you can see this, there is x, there is y, and we can add these two variables together, x plus y. Press enter, and it will create an answer variable. In fact, override the answer variable that was earlier created, and now the value of it is 3. You can create some a third variable to store this result. So z is equal to x plus 3, sorry, x plus y. So and press terminator, and I've not I've asked MATLAB not to echo it, but it still creates this variable z, and the value here is 3. 1 plus 2 is equal to 3. So in order to clear this command window, you can write CLC, and if you want to type in some earlier commands, you can go to the command history with an up arrow. Simply press the up arrow, and you can see all the commands that you have earlier typed, including the date. It creates a log of all the commands that you have typed in and maintains here. So on today, starting from 11:50 a.m., I have been typing in these commands, and you can scroll through all these commands and simply press any one and it will be re-executed. So that was all about the command history. Now this is how you simply create a variable. Y is equal to 4. You can see that there are two variables now, y in lowercase and y in uppercase, so it obviously means that MATLAB is case sensitive. And let's start working with variables more formally. So CLC, I'll clear this. And let's create a scalar. Again, x is equal to 20. So this x contains a single value. So I can refer to this variable as a scalar. Similarly, y is equal to 30. Again, a scalar. So if you want to view the value of x, simply write x. It will echo back the value of x. If you type in y, it will echo back the value of y. So this is how you create scalars, and you can perform the basic operations on all the operations that can be done on scalars can be done in this MATLAB. So some of the operators are plus, minus, and so on and so forth. We'll later on see how scenario changes of using operators when we use vectors and matrices. So as in any programming language that you might be aware of, you can create expressions using scalars and save it in temporary variables, evaluate them, and perform some other functions, predefined functions. So let's go through some of the scalar functions that are available to us. So let's like sine of 10. So it gives this value. You can store it in some variable. Sx is equal to sine of 10. Okay, or sx is equal to sine of x with the terminator, so it will not echo back, but still sx will contain the same value. X contains 20, so this sx is sine of 20. There are other functions like cos of x. Similarly, other trigonometric functions, tan of x, and so on and so forth. You can use this help command to give the description of the various functions that are available in MATLAB. So if I write help cos, So cos here is an inbuilt function. It gives me the documentation related to this function. So cosine of the argument in radians. So it does not take the values in degrees. It takes the values in radians. And you can open the reference page for it. You can also, gives you some hints regarding other functions. If you have some confusion related to how a function works, you can always write, help and the name of the function to give the documentation related to that. So if I write tan of 10, it means tan of 10 radians. Okay, so maybe there is some function which converts radians to degrees. So let's try to find. So to search the documentation, you can use this small text box here. So we are trying to find a function which converts degrees to radians or radians to degrees. So we'll see if there is some function like that. So rad to 2 degrees. So this is the function, rad to degrees. So it opens the help manual for it. So this is the format, rad to dig, and R here is the radian value, and D, the return value, will be the degrees of that particular input value that you passed. So if you want to see how many degrees are 10, how many degrees are 10 radians. So I'll write dig is equal to rad to deg of, let's suppose, 10. So 10 radians to degrees, I'm going to convert it. So I'll not use a terminator to see the value. So 10 radians is equal to 572.9578 degrees, or how many degrees are 1 radian. So it's 57.2958. So you can go through the documentation to find search for different functions that you may use, and so on. There are also functions, like if I write there's a function floor. These are just some examples that I'm going through. Floor of 2.5. So what is floor of 2.5? So it should be 2. So it returns 2. So what is the seal of 2.5? It is 3. Okay. Similarly, seal of 2.1 is again 3. So you can use these functions, use variables to save them, manipulate them, and generate whatever results you want. Okay, so this is all about scalars, how to define scalars, scalar variables, and some of the scalar functions that you can use to manipulate all those values. Later we'll see how to create vectors and work with vectors. Similarly, matrices, some of inbuilt functions for vectors, and some of the inbuilt functions for matrices. So till then, thank you.